right, so now we're talking about section 12.2 on geometric sequences. All right, so now I have a couple of kind of a challenge problem. We're going to first talk about a geometric sequence. What we're going to look is we're going to say how do we find the nth term of a geometric sequence, and how do we find the mean, the geometric mean of a sequence, and finding the sum of a geometric series. So we're going to start with finding you're starting a new job and your supervisor gives you an option. He says you can get a 5% raise each year, or you can have your salary increased by $4,500 each year. What information do you need to make a wise decision on which option do you want? So do you want to go up by a regular rate every year, or do you want a percentage increase? Okay, so I want you to kind of think about to yourself what would be some information that you'd have to solve this problem. I think probably one of the questions you might have is, all right, what's my starting salary? So I'm going to give you kind of a nice high starting salary. Our starting salary is $50,000 for this example. All right, so we have $50,000. And then the things I want you to do, and hopefully by the end of class today you'll understand how to solve this. I want you to tell me if you work 10 years, which is the better option? If you work 25 years, and then if you work 40 years. So of these, which is the better option? Would it be a percent raise or increasing it by a set amount each year? And we're going to come back to this if we have time, and I'll show you how to solve this after we get some information. So today we're talking about a geometric sequence. If you remember, we had a video in class about, we were counting by fives, 5, 10, 15, 20, 25, 30, 35, 40. And that was an arithmetic sequence where you're adding the same number each time. Let me give you an example of a geometric series, or sequence, series, we would be adding them. So here we have a geometric sequence. Now if you notice, what's different here is to get from one to the next is we're multiplying. And here we're multiplying by 2. You might also notice that really what we have here is 2 to the first power, 2 to the second power, 2 to the third power, 2 to the fourth. And that is by design. All right, so we're going to kind of talk about how what you're multiplying by, your ratio, is your base. And then what value is going to have to do with your exponent. So first of all, we're going to talk about how do we find R here? How do we find our ratio? So our ratio is what we are multiplying by each time. How do I get from 1 to a negative 1/2? Same value should then be multiplied by negative 1/2 to get to a 1/4. Now the first thing I notice, I hope you notice this too, is we have a positive and then a negative, and then a positive and then a negative. And what actually happens, and if you think about this, when you have a negative value taken to an even exponent, you get a positive answer. When you have it taken to an odd exponent, it's going to be a negative. So what that means is R has to be a negative. And if you can kind of logically look at this, you go from 1 to a negative 1/2 to a 1/4 to an 1/8. What you're doing each time is you're dividing it by 2, or you can think of it as you're multiplying by 1/2. And so it's going to be multiplying by a negative 1/2. Now what happens here, if it's not so just visual that you can kind of see, oh, it's going down by half. Well, the best way in this case, now before when we had arithmetic series, we said, well, you always have this option of taking the second term and subtracting the first term. And because in an arithmetic series, we were adding. Now, we're going to take the second term and we are dividing it by the first term. So here we're going to take 21 and we're dividing it by 4.2. Okay? Oh, and I just realized I did that backwards. I'm sorry about that. We actually need to take the second term, 4.2, and divide it by my first term, 21. So 4.2 divided by 21 is 0.2. Okay? So in this case, our R is 0.2. We're multiplying it by 0.2 each time. We're going up by a value of 0.2. So our formula that we're going to use to find the nth term of any given value is we're going to take the first term, so a sub n is the last term that we're looking at, all right, nth term. All right, a sub 1 is the first term. We're going to take the first term. We're multiplying it by the ratio. All right, so our ratio here, is what you multiply by to get the next term. n is the number of terms. So let's put this formula to use. So we're going to start with, what is the 17th term? So my formula, if you remember, is my a sub 1 times my ratio to the n sub minus 1 power. Okay? So my first term is 1/4, and then I just need my ratio raised to the 16th power. Why is it 16th power? Well, if I want to find 17th term, I go one less than that. Well, I need to figure out my r now. Well, I told you before, the best way to figure out your r is to take your second term and divide it by your first term. Well, in order to take 1/2 and divide it by 4, the quickest way is to take 1/2 times 4/1. My answer here is 2. Okay? So now I need to take 2 to the 16th, well actually 1/4 of 2 to the 16th, and I get for an answer here 16,384. That's how many, that's going to be the 17th term. These terms go up really pretty fast. Let's do another one. All right, same formula. Now we're talking about, well, we know our a sub 1, our first term, we don't know. All right, what we do know is we know our last term. Our sixth term is 192. We're trying to figure out our first term, and we know that our ratio is 4, and that we were talking about 6 terms, so it would be 4 to the 5th. So the first thing I'm going to calculate is that 4 to the 5th is 1,024 times my first term equals 192. Now I'm going to divide both sides, 192, I'm going to divide it by 1,024. Actually, I'm going to do this on the calculator because I wanted to show you. We have in here 192, and we're dividing by 1,024. We're going to get a decimal answer, but I think it would be probably better, since we were working with fractions, if we did a fraction. So I hit math, enter, enter, and I got the fraction 3/16. So I think it'd be easier if I showed it as a fraction of 3/16. I would have accepted the decimal answer of 0.1875, but I think that fraction is a little bit better way to go. So now we're going to talk about geometric means. Well, a geometric mean, if you remember from an arithmetic mean, it's just a spot. It's just a spot in there. So in other words, when we start with 128, we have 2 spots that have terms in it, and that the last term is 54. Okay? So we still have the same formula that we follow here, that the last term equals our first term. What we're not going to know here is our r, and then it's going to be n minus 1. So our 54 will equal our 128 times some value r to the 3. Now, why did I pick 3? Well, I know we have 1, 2, 3, 4 terms, and so one less than that. So the first thing I'm going to do is go 54 divided by 128, and then I'm going to hit math, enter, enter to get a fraction there. I got the fraction 27/64. That's what r to the 3rd is. So really what I need to do here now is I need to take both terms. I'm going to take the cube root of both terms. I think the quickest way to do it is to take it to the 1/3 power. What that gives us is then our r was going to be 3/4. Well, if our r is 3/4, what I need to do is just take 28 times 3/4 here. So, excuse me, 128, sorry, times 0.75 is 96. 96 times that 3/4, or 0.75, is 72. And then hopefully 72 times 0.75, just to check myself, is 54. So I'm on the right track. So now we're going to be talking about the sum. What happens if we take a sum of a bunch of them? Now here we have an example, and I'm just realizing we can't take the sum of that because we don't know where does it end, how many terms. So we have to be told how many terms are we adding. Okay, so this one we can't quite do yet, but let's look at the formula here. So just like before we had a formula, and our formula for this one, I think with the arithmetic it just kind of makes sense, the first and the last term, and this one doesn't always make as much sense, but it's something we have to just kind of memorize. So we do have a first term. Our r is still our ratio, and n is the number of terms we're talking about. A sub 1 minus a sub 1 times r to the n, and 1 minus r. A little bit more complicated. So let's start with our formula. Let me make sure I have that right. Minus r to the n. Yep, 1 minus r. Okay, so now let's just plug in what we know. What we know, my first term is 14. I don't know oh, I don't need to know my last term. This is the beauty of this one. I remember this now. I need to figure out my r, and I have 1 minus. So I have to kind of figure out my r. So this is where I'd go off to the side and say, oh, I need to figure out r. So what is my r? I need to take this negative 70 and divide it by 14. Negative 70 divided by 14 is negative 5. All right? So each time I'm multiplying here by a negative 5 and then we're talking about 8 terms here, and then this here would also be a negative 5. So then my problem becomes here, what is 14 minus 14 times negative 5 to the 8th. So let's start with what's negative 5. Oh, sorry about that, guys. I kind of got off. All right, so my answer in the end, I was able to kind of calculate it, was 9,000. Here we go, 911,456. Okay? So, first day that we're going to have you work on this, we're going to have you work on page 771, problems 17 through 39 odd. And I'm going to have you just work on that. Good luck.